All right, now we're going to get into truth tables. Truth table is a tool used to determine when a compound statement is true or false. Remember, in the beginning of the video, I said we're going to talk about every statement can be true or false, but when we put them together into a compound statement, we have to see if that would still be the entire thing be true or would it be false. And later on in other videos, we'll get into testing the validity of statements. Now, looking at a truth table, what we do is we set up all of the possibilities that we could have. For example, we just said that P, any statement, is either true or false. Those are your only options. That means when what we do with the truth tables, we put all of the options. P can be either true or P can be false. That's it. It's true or false. The negation of P, remember, is the opposite. So if P is true, then the negation would be the opposite, which is false. If P is false, then the negation would be true. That's how we would do this is the most basic truth table. We're going to kind of build these up for you. Now, let's look at the truth table for a conjunction. And to do this, I'm going to write down an example, okay? What we're looking at is P and Q is true when P and Q are both true. And I'll tell you why. With the and, this is saying P and Q, not or. It means both. That means the only time these two are going to be true together, which is our last column, is if they are both true. Now think about this. I'm going to put down an example just to kind of show you realistically. Your boss promises that he will let you go home early on Thursday and have Friday off. Okay, this is a promise that your boss made. Here's the question. When did he break the promise? This is going to help you understand better with the truth table. With P, now let me show you over here too. I got one more thing I got to do. We were saying, I'm going to do a little tree diagram. With P, we were saying, just to show you how we're going to set up our truth table, we have two options, right? It's either true or it's false. That's it. Now with Q, we have the option of it being true or false. So here's my Q. That can be true or false. And same thing, if P is false, I still have two options for Q. Okay, here, look at the relationship here. P can be true or Q can be true. P can be true or Q can be false. These are all the possible combinations. P could be false, but Q could be true. P could be false, or Q could be false. This is it. Now, I wanted to show you how we find those, but you're going to notice if you memorize this pattern, you won't have to do that every time. Basically, when you're setting up your table for P and Q, you always have two T's, two false, and then Q will alternate T, F, T, F. This will always be the same, but this is where we originate it from. Now, here's P and Q. When does it become true and when does it become false? Your boss promises that he will let you go home early on Thursday, okay? This is saying P was true, so it happened, and Q was true. So he also gave you Friday off. Did he break his promise? No. He followed through on both. We're saying they both happened. That's what the true means. Therefore, P and Q would be true. Oops. Here, this is saying P did happen. It's true. But Q did not. Meaning your boss did let you go home early on Friday, but he did not let you have Friday off. So this is your P. Oops. Let you go home early on Thursday and have Friday off. That's your cue. So he let you go home early on Thursday, but he did not give you Friday off. Did he break his promise? Yeah, he did. So P and Q would be considered false. Here, he didn't let you go home early, but he did give you Friday off. Did he still break the promise? Yes, because he didn't let you go home early. This whole thing is false. Oh, I just did that one. But we can also do that one too because it says that he did not give you Friday off. This one says neither happened. So he didn't let you go home early and he didn't give you Friday off. So that whole thing would be false. In other words, the only time P and Q is true is when they're both true because he has to follow on the promise, and an and means that they both had to have occurred. All right, so that's your truth table for an and. That rule will always apply when we do different problems. Now let's do the or. Okay, the or, think about it. You're saying this or this. Let's take our last problem right up here, but let's change that to an or, saying your boss promises you he will let you go home early on Thursday or have Friday off. When does he break his promise? So we're just changing that whole thing to an or. Now, set up my P. Remember what we just said. Here's your pattern. 2 T's, 2 F's, and then TF, TF. Or, okay, this is saying they both happened, meaning he did let you go home early on Thursday, and he gave you Friday off. So this is fine. The promise hasn't been broken. Now look at this one. This is saying he let you go home early on Thursday. He didn't give you Friday off. Did he break his promise? Well, no, because it's or. He gave you, it says he could give you, right, Thursday off or the Friday. That means he only has to do one of them. He could do both, but he only has to do one. All right, so that makes this one true. Again, we have this one. He didn't let you go home early on Thursday, but he did give you Friday off, and because of that or, he didn't break his promise. He just had to follow through on one, I don't know why it keeps doing that, or the other. Last one, he didn't do either. You didn't get to go home early, and you didn't get Friday off. That's where we fail. That's where it's false, because as long as one of them is true with an or, you're fine. But if they're both false, it's automatically false because he had to do at least one of the two. Here's a word I'm just going to put down here because you might come across this. But if you ended up with a truth table, oops, let me just go up here. Let's say these were all true at the end, the very last one. That would be called a tautology, which is basically a statement that is always true. Now, let's look at the conditional. And here, I'm going to write down an example with this one so that you can understand where this, kind of look at the logic. Now, let's say if you work late, here's our conditional, because remember, that's what the conditional is. On Tuesday, then your boss will give you a bonus. Now, again, the question is always, when does he break his promise? Let's do our table. Remember, these are always the same now that you saw the pattern. So we don't need to really think too hard with this yet. Here's where we're looking at what does if P then Q result in. So let's go over here. If you work late on Tuesday, so that's your P, then your boss will give you a bonus. That's your Q. Okay, so I'll just put that a little in parentheses here. This is saying true and true. So you did work late and your boss gave you a bonus. Well, yeah, that's going to be true. He upheld the promise. Look at this one. This is saying the first was true, the second was false, meaning it didn't happen. That means you did work late on Tuesday, but your boss didn't give you a bonus. But the whole condition was if you worked late, he would give you the bonus. That makes this false. Now, let's look at this one. This is saying that you didn't work late on Tuesday, but your boss gave you a bonus. Did he break his promise? No. It only said he'd have to give you a bonus, right, if you worked late. That was the condition, but this says, okay, you didn't work late, but he still decided to give you a bonus. That was fine. So that's true. And then what if they both didn't happen? So you work late. No, sorry, you didn't work late and your boss didn't give you a bonus. Well, that's true. You didn't meet the condition. So the only time this is going to be a false is when you met the condition but didn't get what you were supposed to get. So a T followed by a false, that's the only time it's false. And when we'll get into that in another video. Now, let's just talk real quick about equivalent statements. This is our last part. Equivalent statements means that they both have identical truth values. And let me just show you visually what this means. Here's all of your statements. Now, let me write down my steps when I do these truth tables. The first step I do is I put down all of my single statements. That's step 1. Step 2, I do my single negations. And you'll see I'm going to apply all of this in a minute. Step 3, I then do my parentheses. If I have anything in parentheses, I do that. And let me just put from left to right. And then step 4, the last column is my entire statement. Okay, let me just show you an example. And we'll do more in other videos, but let me just show you. First, I do my single statements. Those are my P's and Q's. I don't see anything else, so I start off with P and Q. Then I do my single negations. I have not P and I have not Q. I do those next. That's step 2, single negations. Step 3, parentheses. I only have one set of parentheses, and that would be the P and Q. Those go in their own column. But, yes, there's a but here because there's a negation in front of it. That would be my second step after that one. So I'll do my parentheses first, but if there's a negation in front of it, that would be my next column. The only one I have left is this. This was a statement we haven't put together yet, so that would be here. And what we're going to do is we are going to compare these two, what we get at the end. All right, well, let's go ahead and fill in. We've already gone through this with the P. Remember, we just said 2 T's, 2 F's, TF, TF. Now let me explain what we do next. Negation of P. This means do the opposite of everything you just put in this column. That means I'm going to have 2 false, 2 trues. You make everything the opposite. Same thing with here. You're not Q, everything goes the opposite. So it becomes false, true, false, true. Now we do the and. I don't know why that keeps happening. Now we do the and. Remember, we already talked about the and. You can go back to your other truth table for that one, but we said the only time it's true is when they're both true. That would only be here. Everything else is false. Again, this is just review now, this part. Now, notice what this says. I need to find the opposite of what I just found. This says the negation of that. That means I'm going to do false, true, true, true. Okay, that's what that means. The negation means make everything here the opposite. Now I'll go over here. This says to do not P or not Q. I'm going to look at these 2 columns right here and do the or. Now remember, the or says I only have to have one true for it to be true. Well, these are both false. That's the only time it's going to be false. Over here, I have a true, and a true. There's a true at least in every part, every row. So the rest are true. Remember, only one has to be true. Now, this is what we're getting to. This is why we call these 2 equivalent statements, because your end result is exactly the same, and it has to be the same in order. So FTTT, FTTT, these are equivalent statements. All right, the first video is always a lot because there's a lot to cover when we introduce logic and truth tables, and it's so new. But again, feel free to go back and review, and I will see you guys for the next video.